So in today's lesson, we are going to solve for a system of n linear equations with n unknowns using naive Gaussian elimination. And in this question, we have three systems of linear equation with three unknowns. So first of all, we have to represent this system of linear equation given here in an augmented matrix form. So we have the first column of our augmented matrix is going to be the coefficient of S1, and that of the second column is going to be the coefficient of S2, and the third column is going to be the coefficient of S3. So we have and the values on the right hand side. In doing a naive Gaussian elimination, we perform a forward elimination to obtain an upper triangular matrix and use back substitution to solve for the values of S1, S2, and S3. In doing the forward elimination, we intend to make these values goes to 0. In so doing, we consider the first row to be our pivot row, and that 25 will be our pivot element. So we are going to perform an elementary row operation on row 2 and row 3 to obtain an upper triangular matrix, which will make this place 0, 0, and 0. So for row 2, our multiplier is 64 over 25 times row 1 subtracted from row 2. For row 3, our multiplier is 144 over 25 multiplied by row 1 subtracted from row 3. So we have our new augmented matrix as the first row is going to be maintained. So for the second row, we have 64 minus 64 on 25 times 25, which is going to give us 0. We also have 8 minus 64 on 25 times 5, which is going to give us negative 4.8. We also have 1 minus 64 on 25 times 1, which is going to give us negative 1.56. Then this side we are going to have minus 96.208. For the third row, we are going to have 0, negative 16.8, negative 4.76. We have minus 335.968. Now we still don't have an upper triangular matrix because this place is not 0 yet. So we continue with the forward elimination step. Now we want to make the negative 16.8 equals 0. So our pivot element is going to be negative 4.8. Now we have to perform an elementary row operation on row 3. So therefore, row 3 is going to be the multiplier negative 16.8 over negative 4.8 times row 2 subtracted from row 3. So now our new augmented matrix is going to be 25, 5, 1, 0, negative 4.8, negative 1.56. One oh six point eight, negative 96.208. So now the third row becomes 0, 0, 0.7, and we have 0.76 here. Now our augmented matrix is an upper triangular matrix. So we need to perform a back substitution to find for the values of S1, S2, and S3. Now, in our augmented matrix, the first column is the coefficient of S1, the second column is the coefficient of S2, and the third column is the coefficient of S3. Now, in doing the back substitution, 0.7 S3 is equal to 0.76. S3 is equal to 0.76 over 0.7. Now we have our S3 to be 1.08571. For the second row, we have negative 4.8 S2 plus negative 1.56 S3 equal to negative 96.208. Since S3 is known, we are going to have negative 4.8 S2 minus 1.56 times 1.08571 equal to negative 96.208. Now our S2 is equal to 19.6905. Now we have 25 now we have 25 x1 plus 5 s2 plus s3 equal to 106.8. Since we know x1 and s3, let's put them into this equation. We're going to have 25 x1 plus 5 to bracket 19.6905 plus 1.08 571. Now x1 is equal to 0.2907 0.290472. Now our solution vector x is going to be a column matrix of 0.2900472, 19.6905, 1.08571.